In this episode, we'll see about the cooling tower and the cooling tower type. Cooling towers are a special type of heat exchanger that allows water and air to come in contact with each other to lower the temperature of the hot water. In cooling tower working process, small volume of water evaporate, lowering the temperature of the water that's being circulated throughout the cooling tower. The purpose of a cooling tower is to cool down water that gets heated up by industrial equipment and process from the heat exchangers or coolers or condenser. Water comes in the cooling tower is hot called hot, hot water and is collected in hot well from the industrial process and goes out of the cooling tower cooled as cooling water or cold water back into the industrial process for cooling the media. Two distinct types of systems for water cooling and reuse are open type and closed recirculating systems. The third one is one through cooling system. In an open recirculating system, cooling is achieved through evaporation of a fraction of water. Evaporation results in a loss of pure water from the system and a concentration of the remaining dissolved solids. Water must be removed or blown down in order to control this concentration of the total dissolved solids. And fresh water must be added to replenish the system due to the vapor loss. A closed recirculating system is actually a cooling system within a cooling system. The water containing the heat transferred from the process is cooled for reuse by means of an exchange with another fluid or by air. Normally, air is used. Water losses from this type of system are usually small. Open type cooling tower is classified as contour flow cooling tower, cross flow cooling tower, forced draft and induced draft cooling tower, natural draft and fan assisted draft cooling tower, factory assembled cooling tower, and field erected cooling tower. This is the schematic diagram of cooling towers working. How the cooling tower is working. Hot water is admitted at the top from the hot well through hot water pump, distributed through the spray nozzle till come as droplet, and dry air is flowing from atmosphere being sucked by means of induced draft fan. This air come in contact with the hot water droplets. To the latent of evaporation, the water get evaporated and the outer vapor is sucked by the induced draft fan and cooling is effected and the cold water is collected in the cooling water basin and this cold water is out. Evaporative cooling is a process where warm water from an industrial process, heat exchangers, coolers and condenser is pumped to the top of the cooling tower where the water distribution system is done through nozzles. The water then distributed by cooling water tower nozzles to the wet deck. At the same time, air is being drawn through the air inlet levers, forcing water to evaporate. Evaporation causes the heat to be removed from the makeup water. The hot air is naturally rises out of that air. This is the cooling tower working principle. This is the schematic diagram of cross flow cooling tower. Hot water is admitted from the top. The air is at the cross flow horizontally. Fan is there to suck the water vapor. Cold water outlet. The cross flow cooling tower systems, the water vertically flows through the fill media while the air horizontally flows across the falling water. That's why they call it cross flow because the air and water cross paths are flows. Because of the crossing of flows, the air doesn't need to pass through the distribution system. This permits the use of hot water flow via gravity and distribution basins on the top of the tower, right above the fill media. The basins are a standard of cross flow cooling towers and are applied on all units. This is a schematic diagram of counterflow cooling tower. Hot water is admitted at the top and air is flowing from bottom to top in the counter current. This is a fan to observe the suck the water vapor. Cold water is collected at the bottom. In counterflow cooling tower system process, the air vertically flows upwards counter to the water flow in the fill media. Due to the vertical airflow, it is not possible to use the basin's gravity flow like in grass flow towers. As a substitute, these towers are use pressurized spray systems, usually pipe type, to spray the water on top of the fill media. The pipes and cooling tower nozzles are usually spread farther apart so that they will not restrict any airflow. This is the induced draft cooling tower diagram. This is the induced draft fan, drift eliminators, the distributor nozzle. Hot water is distributed through this nozzle from the top, cooling water basin, and cold water. Drift eliminators is provided here to reduce the loss of water and emission while it is distributed from the top. Water droplets should not escape through the induced draft, still lose some water. Cooling tower fans are used on induced draft cooling towers to pull air through the fill media. On forced draft cooling towers, the air is pushed or forced by the blowers at the bottom of the air inlet lower. Fan will be here. And hyperboloid or natural draft, sometimes incorrectly known as hyperbolic. Cooling towers have become the design standard for all natural draft cooling towers because of their structural strength and minimum usage of material. The hyperboloid shape also aids in accelerating the upward convective airflow, improving cooling efficiency. These designs are properly associated with nuclear tower plants. This natural draft is attained by means of chimney effect due to the height of the tower vertically. This will give the chimney effect for this natural draft to the natural draft cooling towers. This is the natural draft cooling tower diagram, and this is the fan assisted natural draft cooling tower diagram. Here is a dip eliminator, water distributed through a nozzle, cold basin, and here fan is used to assist airflow to increase the airflow, drift eliminators, water distribution. Airflow is obtained in natural draft cooling tower systems by way of the chimney effect of the cooling tower's actual structure, which uses the natural pressure differences. Warm and moist air is less dense, which causes it to rise out of the cooling tower into the atmosphere and draw in denser fresh air. The difference between the warm air inside the tower and the cooler air outside creates the perfect airflow. For sufficient airflow to occur, a specific mathematical formula is used to calculate the height of the cooling tower to ensure it is almost as large as the density difference. The natural draft cooling tower utilizes buoyancy via a tall chimney. Warm, moist air naturally rises due to the density differential compared to the dry, cooler outside air. Warm, moist air is less dense than drier air at the same pressure. The moist air buoyancy produces an upward current of air through the tower, optimize the cooling process. The hot water is sprayed from the nozzle within the tower. Natural draft cooling tower also coming with fan assisted type, and it is known as hybrid type. As it appears like a natural draft setup, the airflow is assisted by a fan, so it is called hybrid type. This natural draft fan assisted cooling tower thermal efficiency is up to 92%, so it is very effective. Chimney effect, that is due to the height of the tower, chimney effect or natural draft is attained, which helps to reduce the temperature more effectively. Other two types of cooling tower are factory assembled cooling towers (FAP) and field directed towers. FAP is normally used in HVAC unit. These factory assembled cooling tower systems come somewhat disassembled and are shipped in a few sections ready for final assembly or field direction. Although small factory assembled cooling towers can be shipped intact, FAP cooling towers can be induced type, cross flow, forced draft, or counterflow depending on the application it is needed for. Normally, all the HVAC units uses the FAP cooling towers, which are readily available or readily made in the company itself by the suppliers. Field directed cooling towers are usually constructed on the field destination site. Large FEP is usually prefabricated, marketed by piece, and shipped to the construction site for assembly. These type of towers can be counterflow or crossflow depending on the application. For heavy industrial application or more power needed, field directed cooling towers can be built to exact specification, structure, performance, flame abatement, that is the water vapor cloud formed during the winter season or cold season that can be avoided, and drift. Speed directed cooling towers or crossflow cooling towers are normally used in our country. Open time cooling towers. This is the field directed type cooling tower only. The louvers and distributor nozzles and other packing are come in prefabricated, but is assembled along with the other parts in the site only. This is the FEP product used in the bigger industries for effective cooling water production. Hope you might have understand the cooling tower principle, working principle, cooling tower types in this episode. Do not forget to put your likes and comment in the comment box. Do not forget to subscribe and share it with your colleagues and friends. We'll meet in the next episode. Thank you very much.